Thank you for joining us for another HPL seminar today. It is my pleasure today to introduce our speaker, Dr. Robin Trama, a postdoctoral research associate in the OneUp and NIC research groups here at the University of Calgary Human Performance Lab. Robin completed his BSc and MSc degrees in training and performance optimization under kinesiology at the University of Claude Bernard Lyon 1 between 2012 and 2017. And then he went on to do a PhD at the Inter-University Lab of Human Movement Biology, where his research focused on soft tissue vibrations in sport and their effects on the musculoskeletal system. Since joining the Human Performance Lab in 2021, his research has focused on sports biomechanics, equipment optimization, and performance assessments. And although Robin's research has focused on human movement, his true passion lies with penguins. He has said that if anyone ever offered him the opportunity to study penguin biomechanics, he would take it immediately. But for now, he has to settle with human movement, and today he will be talking about his talk titled Evaluation of Athletic Explosiveness with a Smartphone from Proof of Concept to Explode. Thank you, Robin.
Thanks, Ashna, for the introduction. I'm a bit sad because the app only works with humans. I hope one day it will work with penguins, but that's later work. So when we talk about explosiveness, we think about explosive power, and it's defined as the ability to exert maximal force in the shortest possible time. So you got the notion of strength and speed, and it dictates how quickly an athlete can go from a static position to its maximal output. On the field, it can look like that. So the first video is from Kylian Mbappé. On the left, he's a French soccer player. I'm not cheering for France, but I think right now he's one of the most explosive players in the league. And you can see on every touch he has his way faster than all of his opponents. And he's running like distances around like 40, 50 meters way faster than them. The second athlete I wanted to focus on was Antoine Tissot, who is an handball player playing in France. The video is a bit slow to start. But what you'll see is that it requires explosiveness, but different capacities of explosiveness. If it wants to start. Or not. Too bad. So basically, what we can see from that video is like the kind of efforts the handball player has to do are like between 5 and 10 meters, while during soccer, you might do movement between 20, 30, 40 meters. So it requires different kind of explosiveness. Oh, here you go. Pretty slow. So I'll just skip the end of that video, but you got the idea. So in the lab, when we talk about explosiveness, we think about the force velocity and power velocity relationship. And if we start at the basis in a muscle or a muscle fiber, we know that relationship is hyperbolic. Here at the top left, the muscle can produce its maximal force when you got zero speed. And when the muscle is sharpening its maximal velocity here on the bottom right, you don't have any force production. So when you multiply force and velocity and you get the power, you will see that the maximal power is around a third of that maximum sharpening velocity. If we look at human movements, and here for squat jumps or any ballistic movement, this relationship is linear. So to get this kind of graphs, you quantify the takeoff speed at different weights that you can add on your athlete. And after testing 5, 6, 7 different weights, you can recreate that relationship. And here your maximal power will be in the middle of your maximal velocity. So in terms of terminology, we'll talk about F0 as the maximal isometric force you can produce. V0, the maximal theoretical force you could produce if there was absolutely no resistance. And Pmax, the maximal power output. There is another way to quantify force velocity and power velocity profiles. It's with maximal sprint. When you do a sprint, you will start in a static position, which means your velocity will be 0, and then you can produce your maximal force. At the end of your sprint, your maximal velocity will be your maximal speed, and then you don't have any acceleration left. So your force will be close to 0 because we have to consider like wind and air resistance for that, but it will be really close to 0. So here on that graph, on the left side, you have the ground direction forces, as you can see, as vertical and horizontal. And they also quantify the running speed with a laser velocity, which is the gray lines here, which is confirmed by motion capture velocity with the white dots, and a simple model, which is that black line here. So that simple model is based on a simple equation stating that at each time we can quantify the horizontal velocity based on the maximal running speed at the end of your sprint here, so Vmax, multiplied by 1 minus the exponent or minus the time in seconds minus a time delay, which is basically in your time series when you start your sprint, divided by tau, which is the time that it takes you to get to 66% of your maximal running speed. So they use this equation and validate this equation compared to force plate data. So we have the vertical ground reaction force here, which is basically during a sprint on average equal to your body weight. We have with the squares the horizontal force, which is maximal when we don't have any speed and almost close to zero when we reach maximal speed. And you can compute also the power over time, which will be high in the first few steps and then decrease over time. If you switch the axis and you put the velocity as the x-axis and the power in the y-axis, you can recreate this force velocity relationship based on one single sprint. We also know that for each profile, there is one optimal distance. That means that everyone with the same power output as you will be slower than you on that distance. So if we look at that graph, on the y-axis here we have the time in seconds, which is exactly what that color bar represents as well. We have the maximal power output from 5 to 30 watts per kilo. And in the x-axis, we have the FV profile. So -1 means that your F0 is equal to your V0, and a value below -1 means you have more force than speed, and a value above -1 means you have more speed than force. And here we have a thin red line showing the optimal profile for each power output for this distance of 15 meters. So if we look quickly at that graph, we see that if you want to have faster time, so have like this kind of blue values, you need to increase your power. But then when you reach a certain amount of power, if you want to keep increasing your performance and reducing that time, you will have to play on that force velocity balance to be exactly at the minimum of that curve to optimize the performance. So for that study, they quantified performance of different groups of athletes, from sprinters here to weightlifters at the top of each graph. And each band is a distance from 5 to 30 meters. And the 100% you see here is that red line we had on the graph before. So you can see that some athletes, let's say sprinters here, have a profile optimal between 15 and 20 meters, while weightlifters have a profile that is optimal around 10 meters. So that means that you can play on that force velocity balance to target your training. We also think that in real life, depending on your sport, your position, your play style, you will require to run at different distances of sprinting. So you want to match as closely as possible your optimal distance with what you'll have to do in your sport. So you can compare your current profile and the goal distance, and based on that, you can train specifically to get closer to that goal, and then it will improve how you can reach these goals. One question we asked ourselves at one point is like, can we really translate what's happening on a straight line sprinting and what we've seen on the field? So to test that hypothesis, we recruit 10 female soccer players and we quantify performance on a 5-cone drill that you have previously seen here in this kind of seminar. So we have a timing gate here and participants have to do a few cuts around 5 cones. We quantify sprint profiles with a Catapult S7, which is a device that has been validated by different papers showing it was accurate to quantify force velocity profiles in sprinting. And we also got kinetic data here in the lab where the athletes perform a few different cuts, 90-degree cuts, 180-degree cuts among these ones. So to understand performance, we plotted the mechanical sprinting profile of our best athlete, so the fastest athlete on that 500, and the worst athlete in the dashed line. We can see that F0 between this athlete was not different. However, the peak power and the maximal running speed were greatly different. And when we run correlations to understand how performance was affected by the mechanical sprinting profile, we've seen that B0 and Pmax were explaining why these athletes were faster on that trip. However, none of the kinetic data nor the force was explaining why we had these differences, showing that even for really short bursts of 3.6 meters, speed and power were more important for soccer players. So if we want to evaluate explosiveness, we need specialized equipment. So we can use high frequency GPS, they're really good, but these brands are mostly doing in-game metrics. So they don't have an option to do force velocity profiling, except for StatSport recently, but they didn't really talk about it, so I'm not exactly sure what they're doing. We can also use a radar gun. We know there's some limitation on the acceleration phase because of noise and how the radar gun is getting the speed. We can use a 180 sprint device, which can be used to do evaluation and training. It's just a really expensive device. You got some apps with some wristband to help you time your runs. Pretty good, but give you only time. And you can do these kind of protocols with like loading your different bars and quantifying the speed to get force velocity profile or low velocity profile. And you can use also apps like MyJump, MySprint, but on all of these apps, you need a human input to put timestamp on videos and analyzing the videos one by one. And for all of these, you also need specialized people. You need a sports scientist, you need a coach who knows what to do with the data. So before talking about the app, we also did a proof of concept. So with Sport Insight and MyTax starting October 2023, we got a grant to work on that proof of concept. And to start, we put 3 S7 GPS that have localization, IMU, and running speed as output. And we had a reference on the back, like every other studies. And we also put 2 on the wrist of our athletes. The goal was kind of to imitate a smartwatch or holding something in your hand. So when comparing the results of these 2 different locations, we've seen a pretty good agreement with the catapult device. So if we look at the ICC 2.1, which is basically a measurement of how 2 measures are agreeing with each other, 0.9 will be characterized as excellent agreement between devices. For our power, we had an agreement that was good to excellent. For the force, something that was moderate, close to good. However, for the force velocity relationship, we were pretty far from having something accurate. Looking at the day-to-day reliability, we can add kind of the same values in terms of ICC, slightly better in terms of consistency between measurements. So based on that, we decided to go and keep working on developing an app that could quantify these force velocity profiles just using your smartphone. So the mission of Xplode is to easily and accurately, and I will come back to the accurate later, obviously, to measure force velocity and power velocity profiles in sprinting and give the user a solution to improve their explosiveness more efficiently without using external equipment but your smartphone, without being expensive, and without requiring the sports scientist to analyze your data. So I want Xplode to be like an easy-to-use ecosystem that seamlessly provide athletes of all levels with their explosive athletic ability, giving the coach and the athlete the tools to optimize the training and improve their explosiveness. So after having done that proof of concept in October 2024, it is Christmas 2024, I had a bit of time ahead of me, and I started to work on that app. So that ecosystem is composed of a recording app that you have on your phone. You can simply put a running distance, you click start, you sprint, you click stop, and after a few minutes you have the result that you can see directly on the app or on a dashboard that is available on the web. to kind of see all of your data, your trends, interact with your data, etc. Before diving into these two big points and big parts of the app, I want to talk about how I started. So I'm a researcher. I'm not a web developer. I'm not an engineer. And we tried in the first place to hire someone to do that work. However, even if you know that person, but that person is a student, wants experience, it's still really expensive when you don't have any money to invest. With the tools we have now, I was confident enough to go by myself and say, okay, let's try, let's see how it goes. So now with VS Code and Cloud Code, you can really engineer entire apps. It takes time, but you can really engineer apps by yourself, even if you don't know the language. And you have a lot of resources on internet. Google Cloud will help you to run all of your analysis online without having your own computer. Firebase will manage all of your backends and your data management, security, and storage. And Stripe can help you to manage all the interface to have payment from the users. So if you have an idea and you're not sure where to start, you can start with that and you'll get a lot of answers from what you want to do. The second thing, I'm also just a researcher and I'm not a business person at all. So I look at the Hunter Hub here at the University of Calgary to have some feedback and advice. So I started to use a Launchpad program. It's a 6-month program. Every week you have coaches, you have sessions, you have a pitch competition and up to $1,000 in fundings. I'm right now in the Innovation Sandbox, which is basically a co-working space at the Hunter Hub, where you can meet with other entrepreneurs and you have access to events. They also have like free legal support with the Business Venture Clinic, which is great because if you have no idea where to go, they can really help you how to incorporate, how to draft like IP and patents. And I'm thinking maybe doing the summer accelerator or the lab to market this summer because it's kind of the same as the Innovation Sandbox with a wider network. So we have a pretty cool website explaining all what they do and saying if you don't know where to start, you should also start with them. Okay, so now if I'm starting with the Recorder app, I had a kind of same setup as during our proof of concept. So we had a Vector S7 GPS on the back where we're just looking at the running speed. And to develop the app, I wanted to develop the app on iOS and also Android. So I decided to take 2 phones that were not too recent, but everyone could use. So the first one would be an iPhone 14. And I chose the 14 because after that model, or at that model, they developed newer shock detection sensors because Apple wanted to be able to detect car crashes with your phone. So they really boosted the sensibility or like the range of these sensors. For Android, I use the Google Pixel 8 because they have pretty good sensors going up to 32 Gs, and also because it was my personal phone and I didn't want to buy a third phone for that study, so I used my personal phone. And on top of these, like IMUs range, they have GPS at 1 Hz and all the other IMUs that are sampled at 100 Hz. So using all of this data from the phones, I created my own machine learning algorithm. And basically, I'm putting as input all of my data. And what I get from that is print metrics and sprinting mechanical profiles. So I won't go too deep on what it is, but I'll tell you how you can create one similar. In terms of data, I was feeding my neural network. It was based on 107 participants, including 30 female athletes, and they performed sprint between 25 and 100 meters, depending on their sport, depending on how they feel that day and what they wanted to do. If they were a team sport player wearing cleats, they were doing also a braking evaluation. And if they were team sport and enough motivation, they were also doing a repeated sprint ability test, which was basically 6 sprints of 40 meters with a start every 35 seconds. I wanted to have a database as broad as possible, so I have an age range between 13 and 70 years old, and sprinting speed from 15 to 34 kilometers per hour. It is now around 500 sprints, and I'm still collecting data, so it's still growing every time I'm adding participants to that pool. So to create the right model, I use some resources we have here at the university called the Advanced Research Computing, which is something every researcher or student can access if they ask for. And instead of doing all the computation on your own machine, you can just send that to a cloud at the university. And these GPUs are way more powerful than anything we can have here in the lab. So if you want to do AI at one point, that's a great resource to use. So to create the right model, you can do something called model architecture and parameters tuning, and you have a broad approach called hypertuning, or a more like small step approach called fine tuning. If I had to pay for all of these and using the computer, let's say with NVIDIA, it will cost me a lot of money. I don't have exact numbers. So it's a great resource to have here at the university. So when you want to do hypertuning of your model, you have to consider which kind of architecture you want to have, but also you have to consider the number of layers, neurons, filters, the size of the filters, the learning rate, the learning schedule, the batch size, the activation patterns, and that creates billions of combinations to get to your model. So here, my first approach was to target 3 big architecture I was thinking suitable for my task. So I was training all of these models. So here you have the accuracy, which is likely just the RMSE value. The lowest value means the model is accurate. And you can see I tried around 2,000 models. This is just one iteration. I did that like countless times. So you should be way more than that. And you can see for like the 1400 model, we have an accuracy that is pretty slowly going down. So if we zoom to our top 100, we can identify 4 or 5 models that are way better than the other ones. So based on these 4 or 5 models, you can do what is called fine tuning. So you take these models, and instead of changing everything at the same time, you'll try to change maybe one layer will have a bit more neurons, or I'm adding one layer here, or I'm changing the size of that filter. And then if you do that a few hundred times, you will find models that are even more accurate than these ones. And if we look at our top 100, we can identify one model or 2 or 3 because they're pretty close that work really well for your task. So once I got that model, we have to test the model and make sure you can generalize the result of your model. So to do that, when we have human data, you want to do something called leave one subject out cross-validation. Meaning if I had 107 participants, I was creating 107 models. And for each of these models, the participant I wanted to test was discarded from the training data completely. So when I'm testing my model, the model has never seen the tested participant data, which is exactly what will happen if someone in France is using my app right now. I will never have seen his data, but my model has to be accurate to estimate his positive profile. So that's how you can achieve like true generalization with human data. Okay, now for the accuracy metrics. So I based all my calculations on a 40-meter sprint because that's the sprint for which I got the most data. And as participants were running with 2 phones and they did twice the same sprint by switching phones, I used the average of these 2 sprints. And I have 105 participants here, not 107, because one participant just did 100 meters and the other one turned off the phone while recording, which I couldn't get the data for. So there's a few variables here. The sprint time, maximum running speed, and V0 that have an excellent reliability. The maximal power being good to excellent. And we have the same kind of trends as with our proof of concept, with the force and the optimal distance being moderate to good. And the slope being still not great, but we'll see that's not that important. I also added 2 other variables in MAE, which is a mean average error. So for power, when someone is running with the phone, I can estimate its power with a 1.16 watt per kilo average error. So it can be exactly the same value, it can be between the right value and 1.16 on average. For the optimal distance, that value is 1.32 meters. And based on that and how the models behave, I estimated it was accurate enough to, one, define the athlete's level, and two, is optimal profile. So if we look at the power, so here you have a correlation between the iOS version of the app and the Catapult device, and every point that I plot are the comparison between Catapult and iOS. And so that's the values I just showed you in the table. So we can see it's pretty good at estimating athlete level, and I had novice to elite athletes, but I had no one really like world class running with a power more than 18 watts per kilo. So that tells me that for my next iteration, when I want to train my new models, I will need to find faster athletes and more powerful athletes. Secondly, for the optimal distance, we can see for people with like a higher optimal distance here, we're not that accurate, and that's what causes our intergraph correlation to be just around 0.73. So with that optimal distance, I can define that athlete profile, and on the app, they can set up a distance goal. I'll just come back to it slightly later. And then that's how I can compare your profile to your goals and give you training suggestions based on that. So here, if you look at the maximal power, if I didn't leave one out for validation and just use all the people's data in my model, we have something that is way more accurate, but that won't be really generalizable to all the population. And I just wanted to show you that for the optimal distance, because doing that, we can see there's a real gap here in the data. So these two graphs really tells me I need to find speed-oriented people, and I need to find people who have high power, high speed. So basically what I need is elite sprinters. So that will be kind of my goal during the summer, going through all the tracks, trying to find sprinters and get more data. There's one limitation to my approach is like, we're not sure it will work for all phones. So we know for iPhone 14s and the later models, all the sensors are identical. So if you're using an iPhone 14, 16, 17, the accuracy will be the same. For the Pixel phones, same sensor, we have the same sensors for the Pixel 9 and 10 series. I'm pretty sure we will put the same in the 11 series, except for the A model, that are less expensive and like worse sensors. And the thing we don't know is like how all the other Android phones will behave with my model. Because it's impossible to know all the AMU configuration, it's impossible to know the accuracy of these sensors. So obviously that's something that would need more tests in the future. All right, so that's it for the recorded part. Now I wanted to talk about the dashboard. And so that web app is a real dashboard for athletes and coaches where you can analyze your sprints or repeating sprint protocol. You have stats, a leaderboard, goal setting, a training center, and you can also have achievement and success to motivate your athletes. So there's a demo mode for all of this dashboard. And I will just give you a quick live demo on my data. So this is basically the page you will land on after your first sprint. And you can see you have value about your time, your running speed, force, optimal distance, and power. And I really like to represent the data in 2D like that, because with one look, you can see your maximal force, which will be the y-axis, and your maximal speed on the x-axis. If you do a repeated sprint ability protocol, and that's something you can customize in the app. So for this one, it was before a practice. I did 8 sprints of 30 meters. It started with 25 seconds and a passive rest. So I didn't jog between the sprints. And the app will quantify the performance of all your sprints, your average performance, and calculate your repeated sprint ability index, which is how your average sprint performance decrease compared to your best sprint. In the analytics part, you can see how your performance over the last month changed compared to your three previous months. So you can see kind of slow changes over time. If you're getting better, if you're getting worse, if you're getting closer to your goal. And it also compares your data to your best. So let's say the sprint was May 18 a few days ago. It was after practice, I was a bit tired. And I can see compared to my best, my time was 94% of my best time. My speed was 90%, my acceleration 79%. So we can see just quickly with that color code that I was tired. So that's really a quick indicator to show how your performance can change. For the goals page, and I think for me it's the most important page of the app. So you can select your objective goal, the distance you want to be good for. And you can select different sports, showing like different filters. And depending on your position, as I said, and your sport, you can select different distances. So for me, I'm playing wingers or attacker mid at soccer. And I really think that 17 meters is a distance I should be good for, good at. So then it will create that optimal zone in green, which is exactly the red curve we've seen on one of the first graphs in the introduction, and compares my data to that optimal zone. So as we can see, this is my May 2026 month, and I am slightly on the left side of that curve. So that tells me that I need to work on my speed. And if we go to our training suggestion or how your profile is analyzed, you can see here that I'm 2.7 meters shorter than my 17 meter goal, and it recommends me to work on my speed and my power. So if you go to the training center, which is the last thing I will show you for the athlete part, you have filters that will filter the exercises based on your level and what you have to train for. So you have a few exercises that are proposed, and the one that are suggested will be highlighted in blue. And if you click on any exercise, you can see a description, you can watch a YouTube video, and you can add them to some training program that you can easily find and do to progress. So recently, I just developed that dashboard for coaches and clubs where you can see, well, here we have the HPL, we have 3 teams with biomechanic, Stephanie Shin. Hopefully in a few weeks, this team will be deleted because Mike will be graduating. And you have one up with 3 athletes. And if we look at the one up group team, well, you can see your athletes on that 2D graph. You can also see them with their raw values, and you can sort them, see which one is the fastest, which one is the most powerful compared to average. And you can also see the progress of which athletes are progressing more or less. And that's it for the quick demo. So yeah, if you want to scan the QR code, you can access that app as well. All right. So what's next? So in terms of research, I said I'm still looking for participants. So if you want to scan that QR code, you have just a quick signing sheet to do, and I can contact you afterwards. So if you want to do a few sprints, know your maximal running speed and power, you can scan that. And my goal of recruiting more participants is obviously to improve the accuracy of the app. There's a few modes that are still not released. The 60 and 100 meter mode, I really need more sprinters data so they can get accurate enough. So I'll be able to target team sports and sprinters in one app. And there's also that braking performance estimation that needs a bit more data to get more accurate. One other thing I want to do is to develop a readiness or ready to perform model based on subjective data that you can already set up in the app, also based on your training load that you can also already set up in the app, and with your performance data. So with these 3 kind of value, my goal is to be able to estimate how will you perform at your sport or how will you perform at your next sprint. In terms of marketing and commercialization, I really need to find partnership with coaches here in Calgary and in France. As I say, I'm not a business person, so that's pretty hard part for me. And thinking about new developments, I'm thinking about developing the app for a smartwatch. So you don't have to run with something in your hands. And smartwatches are basically activity trackers. So I'm also hopeful that the accuracy will be increased. And I'm also thinking about opening the web app to third parties. So if someone has a Catapult or a Statsport GPS, they can plug in their sprint data, and then I'll be able to give them their values, their trends, and how to train. What's next for me? Well, I'm still working here as a postdoc in the HPL. So I just joined the biomechanics group earlier this month when I'm leading research project, mentoring students. That's been a lot of fun so far, a lot of cool projects. I'm also considering applying for an adjunct professor position. I think I have a good profile to mentor students and especially kind of bridge the gap between kinesiology and entrepreneurship, help the students see their ideas, use the right tools, and also use all the resources we have here at the university. Before ending, I wanted to thank Alize, Anik, Ashna, Gabri, Ina, Kat, Korai, Lisa, Natural, Rebecca, and Zishan, who worked with me to translate the app in 13 languages. I did the French and the English part. That's why the English is so bad. And I want also to thank Adrian. He's the first one who talked to me about the ARC cluster, and he helped me set it up on my computer, so that was a huge help. Something I didn't mention during that presentation is a group of students in Germany at the Friedrich Alexander University, led by Rebecca and Alexander Weiss, worked on the first version of the web app. So they really created the foundations on what the web app is based. I want to thank Paula at the Hunter Hub because thanks to her, the Hunter Hub is my incubator and I was able to get that my tax grant. And also Bill and Darren as Sport Insights because without them, I wouldn't have had the support to start that. And obviously, thank you all for your attention.
The floor is open for questions. Who would like to start us off? Okay, I'll ask my question then. Why did you start with the phone and not a smartwatch?
Short answer is I had no idea how to program on a smartwatch. I had no idea how to program on a phone as well, but it felt like it was a good first step. Because if you want to have and record data on a smartwatch, you will have to send that data to the cloud. So you will have to send that data to your phone, and then the phone will have to do all the work. And I think that was the easiest thing to start with. And I really wanted the app to be accessible. So without the need of buying any other equipment, everyone has a phone, not everyone has a smartwatch.
Venus.
Nice work, nice thought. I'm wondering about what's the velocity, because you give people like the maximum theoretical velocity they can reach. So how do you get from one sprint, or that you want them to do many sprints, many speeds, so that you can get that? Or is it just from one sprint you can give them that data?
Yeah, it is just from one sprint. So I said like from the initial start, you'll get the value of maximal force. And when they reach with maximal speed, you can quantify the air resistance. So you will have like, I would say 95% of V0 will be your maximal speed. So when I created the app, the user has to create a profile where he has to put its height and weight. So then I can estimate the coefficient of resistance to the air. And I also get every weather data for each sprint. So I'll know the temperature and I will know the atmospheric pressure. So with these four values, I can estimate the wind resistance, and then from maximal running speed, I can find the V0.
Start out with an equation that have tau in it is an exponential.
Yeah.
That was to predict the port velocity profile.
Yeah, so it's a mono-expansional equation, and basically the first data point will be your maximal acceleration, and this equation dictates that your force or acceleration will decrease linearly when you increase the speed. So that's why we can find that strictly linear velocity profile after.
It's a Weibull distribution. That's why the tau is 0.63 or 63.
Yeah, exactly. Yeah.
So is that, do you use that anymore, or now you skip the whole thing because it's all machine learning?
I'm still using that to get data. Slightly different version of that.
Okay. So you use this, you get the data, and then that's the data that goes into
your app, yeah. But the data that it will be given to you afterwards.
Where's the machine learning part, the neural network part?
So I can tell you later.
Okay.
I won't disclose that.
Okay.
Okay, question back there and then Hannah.
Yeah, so when I think of like explosiveness, I think it also goes sort of like beyond just like sprints as well, things like jumping and rotational power. Is it within your scope or an aspiration of yours to include those aspects, like peak jump or broad jump, like those sorts of metrics that you would be at?
There's already a lot of app existing about vertical jumping. So you got the really simple one with just video, but I know now they're doing like markerless motion capture with iPhones, where you can have like all your joint angles, jump speed, jump power. So I don't think that's something that I will go to, especially because there's not a lot of sports where you just need to be good at jumping. Even if you play basketball, well, there's mostly running and then from time to time you jump. There's a few exceptions, like if you do ski jumping, well, you have to be really good at jumping, but I think that's pretty niche.
I'm also wondering a little bit about the neural network side of things. Not asking for your secrets, I promise. But I'm sure that when you run with the phones and everything else that you need for the app, I'm sure you get a lot of data from it. And I'm wondering whether you found that using all of the data that you get was useful and made the network more or the model more accurate, or whether you found that actually having certain pieces of information of that data made it more messy or noisy, less accurate for what you needed it for.
So feature extraction has always been something really important for neural network. But with all the developments we got recently, you can have gating mechanism. So instead of you learning what features you have to input into your model, well, that layer will learn that for you. So you can put as much as messy data you want, well, it will learn to ignore that.
Other questions for Robin? Ines.
The weight loss now, people are very much interested in that. So can you also add maybe how much calories they use and then try to advise on activities for weight loss, because this would be also high demand.
So I said, like, the goal of the app is just to perform one sprint, so it won't be like in-game metrics because you don't want to play the game with the phone in your hands, obviously. So there's a way to quantify training load. So there's a logger on the app, and you can say the sport you've been doing, how long, what's your sessional RP, how motivated you were, etc. You can maybe extract some values for that, saying like, oh yeah, like your training load is good and your performance increases. But I don't think that will be the primary goal or to use that app for weight loss.
I have another question for you. Have you done any validation work yet in terms of your cues that you're providing to your athletes, that you should do this or you should move here on the chart, or certain cues that you showed us in the demo, have you done any validation work to see whether those cues are actually helping them improve, or you need to adjust something in those feedback?
I did not do that. I think that's a pretty good idea. See how people will interact with that. For that, I need more people using the app. It's pretty new and it's not big paid users. So
How many users do you have?
I like not a lot. I think between 30 and 40 people with accounts. But I would say people using it weekly, maybe a few.
Well, everyone started using that. Matt,
If you look at how robust your algorithm is in terms of if, you obviously are saying like fold your phone like this, you press start. But if someone like folds it upside down or if they're like holding it backwards, like how does that affect like what goes into your models? Does it still work? Does it break? Does it like what happens?
It won't break. I don't think it will work as much. So on the app, you got like an instruction panel. You just click, it will just collapse, and you'll get all the instruction on how to prepare for the sprint, what you have to do, and things like that. So I hope that's enough to have people to be consistent when they use the app. And obviously, you have always human errors, so that can happen. It's a bit out of my control, obviously. And yeah, I don't know how much it will change to have the AI going one way or the other way. But the issue with AI, you don't exactly know how your model gets to its results. I have a few ideas because I know what I'm putting in it, but yeah, it's hard to tell without trying to validate that. Yeah.
Maria? Thanks for your presentation. That was really cool. I guess it's more like a clarification. So when we're comparing the accuracy, we're comparing the accuracy of both devices.
So the one I showed was only for iPhones. They are 98.5% similar between the Pixel 8 and the iPhone. Something I didn't mention, they're also 99% similar if you run indoor or outdoor, meaning that model doesn't need the GPS to work. So you can just go to the gym and sprint and you'll get as accurate data as if you were outside. So it was just for iPhones, but very similar between phones.
And for the variable that wasn't as accurate as the other variables, what do you speculate was the reason why? Do you think it was like the sensors?
So the velocity relationship, so that slope indicator. In fact, I'll just come here. So slope is basically how that curve decreases based on velocity. It depends on your maximal force and depends on your maximal velocity. I have some errors for the maximal velocity. I have moderate error for the force. So when you combine these two kind of errors, you end up with an error that is slightly higher. What I suspect is the start of the sprint is way more variable between individuals. You'll have a different starting position, you will have different way to start a sprint. When you run at your max speed or you run like close to your max speed, you don't really have a choice. Like you'll just get your hands going forward and you'll get a pretty stable frequency of your movement. But for acceleration, it's way more variable between people. So I think that's why it's hard to determine F0 and that velocity relationship.
question here, Sinead, and then Ben. In your demo, you suggested some programs and different exercises for people who use the app to add to their own program. How would they choose which one to do, and how does your model suggest which program to suggest?
So when you set up your goal in the first place, it will compare your goal to it will compare your profile to your goal and give you training axes. So here's speed and power for me. And also it will get my level, which is for me advanced level. So it's a bit arbitrary, depends really like on the different like collegiate level, elite level, world class level, but it's based on your maximum power. So with these two kind of filters, if you go to a training center, you can see that these filters, they already set up here automatically. So if you clear the filter, you'll have a bunch of exercises that are not highlighted in blue and the ones that are suggested for you will be highlighted in blue. So it's just based on how far you are from your goal, and if you are far and you have to work on strength, or if you're far and you have to work on speed, and also based on your level.
So if someone does the suggested program, is it automatically gonna update it and give them something a little more difficult after a few weeks of them doing it, or do they have to go in and do that on their own?
They have to do one more sprint. Then if that sprint is better, let's say you increase your optimal distance, you're closer to your goal, or you increase your overall power and you get a better level, well, it will change these filters and give you different exercises. But to change your maximal running speed, maximal power, it's like CX program is a pretty slow process. You won't get faster because you went and deadlift once, unfortunately. So that's why like all the data, the goals are based on our monthly data. So you will have like really slow changes, but that's more what's happening in reality.
Then online question and then Hannah.
How do you see your device changing with time? Given a lot of like high level clubs, professionals, etc., they can't run with a phone or a smartwatch. And do you see you develop a similar, I guess, measurement device as Catapult, something that other people can wear, not on their hand or wrist, or sport doesn't allow that?
So I don't think I have the knowledge and the money to create a device that is as good as what Catapult Sports are doing. That's why I was thinking about third-party integrations to my data. So if I can work with them and say, oh yeah, we can just create a small protocol, a sprinting protocol, kind of the same as a recorder app, but instead of recording the data from your phone, it will just get the data from your Catapult system. That would be great. Can also, I know some people are trying to do force-sensitive profiling in games. So you get all the data points during a game and you try to identify the phases where the athletes went from static to maximal speed, and then you analyze that curve and then you get your force-sensitive profile. So I'm pretty sure I won't go to that kind of development. Why not developing like a small, so I know I don't need GPS, I just need IMUs, and IMUs are really cheap. You have a lot of trackers now without a screen, without anything, but just basically an IMU and a connection to your phone to get your data. Why not doing that? So why not having a partnership with these kind of companies? That could be something feasible as well.
Online question.
Okay, go ahead, Keenan.
Yeah, thank you. Interesting talk, and thanks y'all for hosting us. I wanted to follow up on the question about when you give this to people, they're all going to hold the phone differently. So a little bit of shameless self-promotion. In 2024, we did a paper where we systematically moved an IMU by 5 centimeters, and we found that there was about a 1G difference for people running. I think the max we had was about 7 meters per second, so not even sprint speeds. I'm looking at my phone and it's about 10 centimeters. So I'm imagining that you're going to get differences in excess of 1-2G if somebody's holding it the wrong way. So how do you think that that kind of error would affect your model and your accuracy?
It will affect the accuracy for sure. I think if there's an overestimation of the acceleration, the running speed will be overestimated and the other way around. I didn't see these many people holding the phone differently. And I think it's pretty hard to control. Even with instructions, you know that people will always do different things. The movement is pretty linear, I would say. Like the top of your phone wheel can always mostly point at the forward way and going slightly up. I would be maybe more concerned about the gyroscope data compared to the acceleration data. Because like if you hold your phone differently, the rotation might be different, but the linear movement shouldn't be affected that much. But it's hard to answer without looking at the data and knowing what's happening. Obviously.
Okay, Hannah and then Walter.
I'm wondering if I use the app and my main recommendation from the app is that I need to increase my power. I noticed on the exercise or the training center, it might have been, that the exercises were like resistance training type exercises. So if I get recommended, let's say deadlifts or something of that resistance training type, are those exercises changing based on how powerful I am in that moment? I guess I'm wondering if I'm comparing myself to you or to Ashna, are we getting different exercises just in regards to that power output? And how do you decide what exercise is associated with what power? If we're all doing the same sprint, like distance will matter, obviously, but if you're increasing power, my brain is thinking, if I'm increasing power and you're training for 17 meters, I'm training for 12 meters, it's the same power that we're increasing, if that makes sense.
Yeah. So based on the different levels, I feel like these exercises will be basic gym movements. And obviously there's something that is like a Trama deadlift. You can do that if you have no experience. That's a really safe exercise. But also if you world class, you can load that bar a lot. That's also a really good exercise if you world class. So that exercise, I think anyone can do it. The only limitation will be how much weight you can put on it. So there's a few things that describes exercise and how much weight you should put, how many reps you should do, etc. But then it can be individualized that much. So I won't be able to tell you, oh, you have to put 100 pounds, Ashna has to put 200 pounds, she's way stronger. I have to put 50 pounds. So yeah, it won't be that way. But there's some exercises that there's like a box squat, for instance. Once you understand the movement and you have enough power development, after being intermediate level, you won't need to do that exercise. That would be too easy for you. You can put weights or whatever, but like the muscle, like the recruitment pattern, the difficulty of the exercise won't be good enough. So as soon as you have a level better than intermediate, this exercise will be recommended to you.
Okay. Walter?
Great, thanks. It's not really my field, so I'm not sure if I understood everything. But I have a couple of basic and a couple of applied questions. And the first one is, in that three-dimensional diagram that you showed, you had a red optimal curve. How do you get that optimal curve?
So there's different ways of doing it. You can create an equation that will calculate the time based on power and profile. You can also simulate the time and find what would be your optimal profile. So there's different ways to approach that. But basically for each power and each profile, you will compute a finite time, and then you just create that hyperplan.
So optimal for what? This curve is optimal for what? If I'm on that curve compared to when I'm not on that curve, why is it better for me to be on the curve? Why is it more optimal?
So if, let's say, you produce a power of 20 watts per kilo, which is baseline here, and you are where my mouth is, was.
Yeah. See?
Here, your time will be 0.05 seconds slower than the optimal profile for that same power output.
Okay, so it's a timing thing for a given amount of power. That's
exactly,
nice.
yeah.
Okay. Great.
So anyone with the same power output as you will be slower than you on your optimal distance.
And the other question that I had is, there seems to be this assumption of the linear relationship between power and running speed, or power and speed of running. Is that this one on the right? Yeah.
So the power is quadratic compared to speed.
Oh, sorry, I meant the force velocity.
Yeah, the force velocity is linear.
Yeah. Yes. And I didn't quite understand this graph, because what ground reaction force is that becomes zero when you run fast?
So it is the average horizontal vertical force. So obviously you'll have a negative peak because you have a braking phase and then a pushing phase, but on average, it will be close to zero because you're not accelerating anymore.
Calculate essentially the impulse of the anterior, posterior, and then when it becomes zero, then you don't accelerate.
Yes.
Okay.
So impulse average would be kind of the same.
I guess to have the same speed, it needs to be slightly positive because you have a little bit of air resistance you need to make up for that.
Yeah.
And so you have a lot of points there, at the bottom end.
Hmm.
But then I guess if I understood correctly, then you extrapolate to the maximum.
To the maximum force, yes.
So how confident are you that line is linear when you get towards maximum force?
So when they did that study, so this one is a validation study in 2019 of the study they did in 2012. And yeah, obviously they've seen, like, especially in the starting blocks, we'll have a different kind of, will not be on the curve all the time because that's a different start. You start in a really, really different position, so you can produce more force because you will be hand on the ground. You have a starting block, so you can really push horizontally. So that's why that start is slightly higher. And I think what we have to focus more here than the ground reaction forces are the dash line by the linear transducer. So that linear transducer is like the running speed you'll have and how you can derivate your full velocity profile based on time, like 100 time passes per second, and you have the velocity. So this one will be the kind of the gold standard from my perspective, because with the full plate, as you said, like you have the start and then you have a big amount of time before the next step and etc. And you have a bit of space between 0 and 4 meters per second. So I would say, like, for me, the gold standard would be more like this dash line, because you can quantify, even if you don't have the force, as you have the speed, you can quantify the acceleration at every point, even between two steps.
And more applied question, when I studied in the US, I always saw when they recruit American football athletes, they have them do a 40-meter test.
40-yard.
So what do you think about that based on this? I mean, is that a good test, or would you, based on your results, would you suggest that they actually select their people differently and maybe select somebody that's a blocker at the line would be doing a different test than one of these people that runs far and gets the ball?
Yeah, I really think we should individualize the testing to what we want to see. And yeah, like a quarterback will not run as much as any other position on football. I don't know nothing about football. Or like a blocker, will never run like 40 yards, or most of his action will be at maximal strength, not maximal speed. So I don't think they do 40 yards for these kind of positions anyway. But if you do 40 yards with my app, with your entire rosters, you can see which athlete will be force oriented, which one will be speed oriented. And if you set individual goals, you can see how all your roster will behave and how you can quickly identify 2 or 3 groups of training and athlete that needs to work on the same qualities.
I was impressed by the videos that you showed now, Mbappe, how fast he is. And so is he fast, or are soccer players in general slow? And that's why he appears to be fast. Do we know anything about sprint speeds over certain distances and can compare that to like track and field athletes?
Well, if we look at Usain Bolt, his max speed is 46 kilometers per hour. I think Kylian Mbappe on a soccer field was 37-ish. So that's almost 10 kilometers per hour of difference.
It's different, it spikes on and track compared to grass and so, but yeah.
So I wouldn't say Kylian Mbappe is slow.
So 37 kilometers per hour.
Yeah, 37.
So that's a little bit more than 10 meters per second.
Yeah.
So that's like running an 80 meters in 10 seconds, which most good high school sprint athletes could do.
Yeah, I think as I said, like on the track, it would be a bit faster than that.
I would assume you would be faster than that.
But that's also how the sprinters train their speed all the time. If a sprinter has you to use the app, it will be super easy because you'll say, oh, my distance is, well, it's capped at 40 meters because anyway, no one has an optimal profile more than 30, 35 meters anyway. And you will have to work only on your speed. So sprinters, since they start to track, they are working on their speed. Soccer players, until kind of recently, they were not even going to the gym and they were not even doing strength and conditioning. It's not something that was really in the sport. And I think we've seen faster players now because they start to do that. But I also think they don't have exactly the tools to define when an athlete needs to work on his speed or his power or his strength. And that's why maybe like soccer players are slow in comparison to track and field.
It's really interesting though, because I just recently watched a rerun of the 1972 World Cup where Brazil won. And when you watch those players,
They're slow?
it looks really slow.
Yeah.
Again, I have the feeling I could have played there.
I'm sure you could have, yeah.
And today, it's much faster, they sprint much more, and they run much more. So not only do they seem they have to be faster, but they also need to be able to run much more. And that's kind of a dual thing, you know, you need to be able to run 10 kilometers now with intermittent sprints, but at the same time, you need to be fast. And therefore, if you have to run for that long, a relatively long distance, you know, you probably cannot be a super good sprinter because I think Usain Bolt would be pooped out if he had to run 10 kilometers in a soccer game. You know?
Yes. So that's why I wanted to include that repeated speed ability testing in the app. Because if you do team sports, as I said, you have to be fast, everyone's getting faster, but what you have to do is repeat these sprints all the time, over 90 minutes, with a few seconds, a few minutes of rest every time. So I said, like, you got that balance between like being super fast, but also being able to repeat these sprints.
I watched once, just as a sideline, I watched once this video when a UK soccer player, an English soccer player, Georgie Best, was a really good soccer player, I don't know how many years ago. And they had a game where they only filmed him, so you saw 90 minutes and you only saw him. And the big surprise to me was, and I guess everybody who plays soccer knows it, but the big surprise to me was how little time he had the ball. I mean, virtually, you know, like a fraction of the time. It was very, very small, like, I don't know, 20 or 25 touches and, you know, and so that's the other thing that, you know, most of the time people run and they don't really are directly involved in the game.
I think like players like Mbappe got the ball more often now because they're fast enough to find the space and ask for the ball in the right space at the right time.
Yeah.
If you're not fast enough and you don't move your other defender close by you, you'll touch less ball because you'll never get the ball. So I think it's kind of how modern football, modern soccer evolved. Is like now you have to be fast because you need to find this space. You don't have longer balls, and because we still have an offside rule that was not there a long time ago. So you can be just waiting for the ball in the open side. So you have to be fast and faster than your opponents.
I always find that the soccer field, the soccer pitch is too small for the men. It's great for women's soccer. I think women's soccer becomes much more attractive because the men, they are so fast that there's not enough room there to really do good things.
It feels like it's pretty big for me. I like to run, but it feels like it's really
Anyway, completely different questions. Why would you like to study penguins?
because they walk super interestingly. And they waddle.
You want to analyze their walking?
No, sprinting, but I've never seen penguins sprint before, so that will be a lot of training first, and then maybe observe.
You're a fabulous swimmer, so I thought you wanted to look at the swimming.
Yeah, I mean you can have fun underwater now, so why not? But I know even less about swimming than running, so.
Okay, there's one last question Mauro wants to ask.
Three things. First, 2 days ago, a group of Chilean scientists discovered a new penguin after 100 years in Antarctica.
Cool.
So cool.
When are we going there?
Whatever you want.
Cool.
So my question is, first of all, congratulations. I know that you have been working a lot and quite alone. There's a lot of effort put there. So related with the legal aspect of your recommendation, because sometimes, of course, this app could recommend it or not, but what is your situation about recommended exercise, knowing that that could produce some injuries, whatever? That is the first question. And second, could you model, predict somehow, or are you considering to take that data that you are having and match it related with certain rate of injuries and recommend also not just training rather than maybe you should rest?
To answer your first question, when you sign up, you have to check a box saying that you read the privacy policy and the end user agreements. And even if you did not read that, you check the box. So basically I'm protected because it says that it's recommendations. You have to warm up before you sprint, you have to be careful with the exercises, etc. Then for your injury question, so when you do a readiness survey, you can click on any part of the body. You can choose any muscle. You can choose if you have an injury there, and you can validate that. So my goal, yes, will be to use this injury logger with like your also a session logger to better predict readiness, injury risks. But for that, I will need to create a protocol that is way more focused on that, with teams, with a coach that really wants to do that, meaning that all the athletes of the club has to do a readiness survey a day, log all the sports they're doing, log all the injuries, being really consistent at it. So I need to find that coach first. That would be really interesting in doing that. And then that would be one of my goals, yeah. Because all the data can already be input to the app and then read through by any model that you want to develop.
Follow up, maybe the last one. How much it costs, the app?
For people, for me?
For people.
For people. Well, you have different kind of subscription, but the basic one will be $3 or $4 a month. You get your analytics, you get your sprint data. There's a big free tier, like all the single sprint data and RSA protocols are free. And if you want the training suggestions, more like $7 a month.
Okay, with that, let's thank Robin for his talk.